About 85 million years ago, near the end of the age of the dinosaurs, an unusual event happened here in what is now Wetumpka. You may have noticed the hills east of town, strangely arranged in a semicircular pattern, or the exposed rocks oddly bent pointing skyward. Could this have been the result of an incredible explosion caused by a meteorite from deep space? Current research says it was. Without question, this event was the greatest natural disaster in Alabama history.
This impact crater formed in shallow marine waters. It was formed in the ocean back during the age of dinosaurs, when the ocean level was much higher and the waters of the Gulf of Mexico came all the way up to the foothills of the Appalachian Mountains. And so Elmore County was underwater, and this object struck in the water.
A basic understanding of the geology of Alabama was non-existent until the late 19th century. State geologist Eugene Allen Smith then traveled through the Alabama countryside, identifying geological features and drawing the first Alabama geological map. In the summer of 1894, Dr. Smith visited Wetumpka, and in particular the farm of Adam Ensslin, an original German settler who established a farm on what was previously Native American territory. After the visit, Dr. Smith wrote, "In my opinion, it is difficult to explain the unusual geological features at Wetumpka, except to assume a depression of several hundred feet." Tony Nethery, a member of the survey team, held a news conference to announce his findings that showed Wetumpka to be an impact crater site. He further stated, a meteorite having a trajectory possibly inclined to the south plunged either into a coastal plain or into a shallow water bank. During the summer of 1998, Dr. David King and Tony Nethery led a team of investigators determined to find the needed evidence of a true impact crater. To obtain this proof, a drill core was needed from inside the crater. From June through August of 1998, 2 wells were drilled at Crater Center.
All these drill cores were at most 600-700 feet, a couple of them were less. We think that there may be 1,000, 1,500 feet or more of crater filling. So we've only just barely scratched the surface with our drilling campaigns, but they have been very instructive in helping us understand the origin of the crater by looking at the rock cores and how the crater bowl filled in, at least in the upper parts of it.
One line of evidence is meteorite shock damage in mineral crystals.
The quartz crystals in the bedrock in a place like Wetumpka have experienced very high pressures from the impact of this asteroid. And it's this really high pressure that's applied over a very short period of time, an instant really, that creates internal damage inside the quartz crystal. And these, under the microscope, look like a series of parallel, closely spaced lines. And that is strongly indicative of a meteorite impact. There is no other place where we find that kind of altered or damaged quartz except in the walls of nuclear test pits. Without this information, we wouldn't have as much of the story about the history of the crater as we do. We certainly could use more drill cores, and we plan to seek money to do more drilling at Wetumpka. The cores are archived and stored in little boxes that are designed to hold the core. They're 2 to 3 inches in diameter rock cylinders, and we have that at Auburn University, where it's permanently archived for research purposes. So we've done research on the cores. There's much more work that could be done on the cores, and in the future there'll be probably new techniques that will tell us even more from these rock cores. So they're a real treasure trove of samples, the likes of which we could never obtain by looking at surface outcrops.
After examining the evidence obtained by the 1998 drilling project, Wetumpka was officially established as an impact crater. The crater can be seen by conducting a driving tour of various sites.
Very often, these tours include places where you can see the rocks that are steeply dipping in the rim, especially the western rim, where we have hard, shiny crystalline rocks, and they're dipping at a steep angle, mainly toward US 231 in most places. Within the crater, very often these tours show people rock strata that are highly deformed and dipping. This is very unusual to see in this part of the coastal plain. And very often the tours also take the groups up to a high point on the rim, and then you look across the crater. You see the high ground in the center of the crater, and then you see the rim on the other side. And this, combined with, say, looking at a map or an aerial photograph, you can see where it is you're looking and compare that terrain with say, an aerial view. And those things, most people have remarked, have been something they could appreciate, that helped them understand that this was and is an impact crater, and the dimensions of it. When you look across it, you're looking over a distance of a better part of 3 miles. It's a substantially sizable feature. Well, I wanted to say a heartfelt thank you to the local landowners who over the years have allowed us to work on their property with their permission. Obviously, without that kind of access, we would not have been able to do nearly all the research that we presented here and I've talked to you about.
It is extremely likely that this place is the center of Alabama's greatest natural disaster.